Hello all, today in this video we are going to see the RNN email detection classification. So previously we have worked, this is a continuation video only. Previously also we worked with RNN only. So previously we made some additional layers like dropout and also an learning rate with Adam. So in that video itself we would have said that what is the change without working with this dropout and also without using the learning rate. So in the previous video we have changed that what is the thing which is happening without dropout. So without dropout we are getting some increments, and here we are going to work without learning rate. So what is the thing is without dropout, why we are getting improvement means with dropout there is a drop rate, right? So it should be declared in such a way like it should not affect the system's or models performance. It should only increase. So previously the dropout rate which we have specified was 0.5. So if we are giving some different dropout rates means it may increase the performance of the model. So that also we will check on the later on video. So here we are just checking with the late learning rate. So previously what we have said is while working with a different learning rate we will get some improvements, and also if we are not providing some improved or good learning rate, that will also deviate the system performance or the model performance. Now we can just move to the mm, code description. So first for that we are importing the libraries, then we are loading the data set which we are using. So our data set is having some null entries. So since it is having some null entries we have to reduce it or remove it. For that we are using the filna function and we are reducing the null entries. Next we are pre-processing the text. So before that we are creating X label and Y label. The X label here makes is given as text and Y label as labels only. So within the text we are calling the email text, and within the labels we are calling the email type from the data set. Then we are making the use of the label encoder, which is a pre-processing function which is going to normalize our data. And also since email type is the target type, to just this is and just additional code. If you need means you can use, or else you can just omit. Why? Because email type is the target one, so we are just checking that which target is higher. So our work is a binary classification work, and since binary classification we are having two classes like safe email and phishing email. So when compared to this phishing email, safe email is high. So this is just an optional one. If you need means you can import or use in your code. If not, you may omit it. Then we are making use of the train test split function with the text and labels, and we are giving the text size as 0.2, that is 20% will be taken for testing and remaining 80% will be taken for training. So if you want some different train or test size means you can also just change it over this in this test size place. Then by using this we are determining four variables like x train, X test, Y train, and Y test. Then within this X train and X test, again we are making with the use of the tokenizer, because we have to convert this text. It is in text format, so we have to convert it into integers. For that we are using tokenizer. Again we are using the padding function to pad sequences function to pad this data, and this pad data only we are using within the RNN fit, that is the training. Then we are just calling, this is the first RNN which we have declared. You may notice that we are having some different layers like sequential, embedding, simple RNN, and dropout layer, and then dense layer and an optimizer. Within this optimizer, we are using an Adam learning rate as 0.001. So for this, we are worked or trained for nearly 10 approaches, and we have got values for accuracy, loss, validation accuracy, and validation loss. So we just checked with without using this dropout rate. Here we have, you may notice that within the dropout rate we are using 1.5. So here without dropout layer, not a dropout rate, without dropout layer, here we are using. So in the next video we will check with the different dropout rate. So here we have just deleted the dropout layer, and you may notice totally the dropout layer is reduced. And now again we are testing for different 10 approaches. So here you may notice the results of accuracy, loss, validation accuracy, and validation loss. And when compared to this accuracy and validation accuracy of this previous model and this model, definitely there are improvements only, not decrements. There are improvements only. If you notice, means here we have got the accuracy as 7117 and validation accuracy is 6247. But here if you notice, means here obviously it is increased, since maybe due to the dropout rate has to be changed. But since we are not changing the dropout rate, there may be some decrement with this validation accuracy. So now in this video we are just deleting the Adam dropout rate also we are deleting, and also we are deleting the learning rate from the Adam. So previously the learning rate which we have specified is 0.01, so that we have neglected, and we are using the default Adam optimizer as such. So this is what the accuracy which we have got. So here also if you notice, means definitely there are improvements. Why? Because the Adam learning rate which we have specified is not less. Again we have to decrease it, or again we have to increase it based on our data set. So since we are using, though we are using some manner that is user defined one, it is not increasing the performance. So now already we have sound manually, but still we can just make an graph oriented difference to just see whether there are improvements. Definitely there are improvements only. You may notice with RNN, with no dropout and without no learning rate. But more or less there are not much improvements, but still definitely there are improvements. So within the next video we can just check with, while working with the different dropout rates and some different learning rate with this Adam, to just notice that whether it is increasing or decreasing the model's performance. Thank you.